जश्न है भारत, रग रग में है जीत की आदत, ऐसा हुनर दुश्मन की सलामी दे। तू सूरज हम तेरे उजाले, तुझसे जुदा नहीं होने वाले, आखिर तक हम सफर तिरंगे के। चैरित जो नस नस में है, अलबाजी फिर बस में है, इंसान के हिंदुस्तान बोले। सुजलाम सुफलाम मलयज शीतलाम सस्य श्यामलाम वंदे मातरम। सुजलाम सुफलाम मलयज शीतलाम सस्य श्यामलाम वंदे मातरम। ज़मीन आसमानों पे आई मुमकिन है दो जहानों में, जज्बे इरादे और ये जुनून बनते हैं दिल के कारखानों में। पहुंच गए अंबर से आगे, धरती से फिर भी बंधे हैं धागे, रहते वतन की मिट्टी से जुड़ के। जय हिंद जो नस नस में है, हर बाजी फिर बस में है, जिद ठानेंगे हिंदुस्तान बोले। सुजलाम सुफलाम मलयज शीतलाम सस्य श्यामलाम वंदे मातरम। सुजलाम सुफलाम मलयज शीतलाम सस्य श्यामलाम वंदे मातरम।
Good evening, everyone. On behalf of Kalam's Institute of Youth Excellence, ISRO Space Tutor, I extend a warm and enthusiastic welcome to all our learners, dreamers, and future explorers joining us today. I am B.Deepshika, student coordinator of KIYE, and I am glad to be your host for Lecture-6 of Aryabhata Space Utsav, a year-long online lecture series aimed to bring the marvelous of space science right to your screens. This series was started to honor Aryabhata, India's first satellite, and to spark scientific curiosity among students and educators nationwide. Our theme is Space is the Next Destination. Let's explore it. And today, we continue our journey with a very special session. For those who are very new to us, Kalam's Institute of Youth Excellence is a non-profit organization that carry forward the vision and mission of our beloved Dr. APJ Abdul Kalam sir. Our goal is to inspire and guide young minds, help them grow their skills, and prepare them for a bright future. KIYE is an organization leading by the students for the students. KIYE has been organizing various flagship programs and initiatives to reach every corner of India. This Aryabhata Swarna Jayanti Space Utsav is one such initiative, organized to commemorate 50 years of India's first satellite Aryabhata, and to inspire young minds towards space research and exploration, where you can interact with our guests through Q&A session. Let us now take a quick look at a short audiovisual presentation that showcases the vision, achievements, and impact of KIYE. Now, the video starts.
जश्न है भारत, रग रग में है जीत की आदत, ऐसा हुनर दुश्मन की सलामी दे। तू सूरज हम तेरे उजाले, तुझसे जुदा नहीं होने वाले, आखिर तक हम सफर तिरंगे के। चैरित जो नस नस में है, अलबाजी फिर बस में है, इंसान के हिंदुस्तान बोले। सुजलाम सुफलाम मलयज शीतलाम सस्य श्यामलाम वंदे मातरम। सुजलाम सुफलाम मलयज शीतलाम सस्य श्यामलाम वंदे मातरम। आई ज़मीन आसमानों पे आई मुमकिन है दो जहानों में, जज्बे इरादे और ये जुनून बनते हैं दिल के कारखानों में। पहुंच गए अंबर से आगे, धरती से फिर भी बंधे हैं धागे, रहते वतन की मिट्टी से जुड़ के। जय हिंद जो नस नस में है, हर बाजी फिर बस में है, जिद ठान के हिंदुस्तान बोले। सुजलाम सुफलाम मलयज शीतलाम सत्य श्यामलाम वंदे मातरम। सुजलाम सुफलाम मलयज शीतलाम सत्य श्यामलाम वंदे मातरम।
That was a memory recalling video of KIYE. Now, to give us a deeper understanding of KIYE and its mission, I now invite our passionate student leader, Miss Sayakshita, to share a few words about her experience in KIYE. Miss Sayakshita, the mic is yours.
Good evening, all. This is Akshita, a student coordinator at Kalam's Institute of Youth Excellence. Being a part of KIYE, I have not just gained knowledge, but also improved my skills like leadership, teamwork, and time management. Most importantly, KIYE has given me the confidence to take initiative and work towards my goals with positive mindset. This platform has given me an amazing journey. As a student coordinator, I got an opportunity to involve myself in various events like organizing the events and managing communication to collaborating with mentors and fellow students. Each of these experiences has taught me something valuable. As a student coordinator, I have been part of some remarkable events like Vignan Vaibhav. It was truly overwhelming for me to be part of such a massive event where nearly 1 lakh people have participated, celebrating science, innovation, and the spirit of learning, for which I'm honored for receiving an award as an active student coordinator. And coming to Aryabhata Space Lectures, where we get a golden opportunity to learn directly from our scientists from NRSC ISRO. I have experienced the doors opening for the space explorations to the students, making us curious, inspired, and excited about our future. To all the students watching, I would say KIYE has been an incredible journey for me. I wish to continue learning and growing here. If you're someone who's looking for a platform where you can grow, inspire, and become a better version of yourself, I strongly encourage you to join KIYE because it is the right place where you can sharpen your skills and ignite young minds. Thank you to our chief mentor, Dr. G. Satish Reddy sir, former chairman of DRDO, for constant mentoring of KIYE, and forever grateful to Dr. V. Narayan sir, chairperson of ISRO, and Dr. Prakash Chauhan sir from NRSC ISRO for continuous mentoring and support to Aryabhata lectures. And thank you Naresh Indian sir, founder of KIYE Foundation. Thank you KIYE. Jai Hind.
Thank you so much, Miss Akshita, for that inspiring journey. Now, let us take a look onto the video of Miss Drakshi sharing her experience in KIYE.
Hey everyone, I am excited to share my journey with KIYE Kalam Institute of Youth Excellence. From being an audience member to becoming a student coordinator, KIYE has helped me learn, build confidence and develop teamwork skills. I have even met inspiring personalities like ISRO chairman Somnath sir. What I love about KIYE is its focus on personal growth and nation building. We are working to strengthen India's defense and make a positive impact. If you are looking for a platform to unlock your potential and become a leader, join KIYE, hurry up and be a part of something amazing.
That was a motivating video by Miss Drakshi. Now comes the highlight of today's event. It is my privilege to introduce Dr. V. Seshagiri Rao sir, Ph.D, FAeSI, FIE, FIETE, FAPAS, former distinguished scientist and associate director at ISRO. Dr. Rao Garu worked at the Satish Dhawan Space Center, Sriharikota from 1976 to 2015 and retired as a distinguished scientist. He also served as Professor Satish Dhawan at ISRO between 2015 and 2018. He has successfully held many key positions at ISRO, including Associate Director, Deputy Director for Range Operations, Project Director for the Multi-Object Tracking Radar, Deputy Director of Vehicle Assembly and Statics Test Facility, Controller and Chief of Administration and Chairman of the Standing Review Committee for Software Development. Dr. Rao Garu's special accomplishments include his participation in all ISRO launches for more than 39 years. He was responsible for the realization of the state-of-the-art machine control center, and as a project director, he designed and realized the first phased array radar in India and the largest in Asia. He has served as a range operations director for 7 PSLV machines, handled data processing for 6 PSLV and 3 GSLV flights, and played a key role in the Chandrayaan 1. He also chaired the GSLV D5 recovery team after a launch abort and guided integration of PSLV and GSLV vehicles on launch pads. His awards includes the Space Gold Medal from the Astronautical Society of India, the ISRO Merit Award, and multiple performance and team excellence awards. He has also been facilitated by the government of Kerala as a part of Mangalyaan team and honored with the Engineering Sevaratna Award in 2021. Dr. Rao Garu is a member of numerous professional bodies including IETE, IEI, AESI, Andhra Pradesh Academy of Sciences, and Astronautical Society of India. He is also a life member of several prestigious organizations such as an Indian Science Congress Association, the Indian Society of Remote Sensing, and the Society for Small Satellite Systems. He has published more than 65 research papers, guided Ph.D. and MTech students, and authored a book in Telugu on Mars orbiter machine. Dr. Rao Garu has also represented India in international conferences in Japan, Spain, and across the country, delivering keynote addresses and leading technical sessions. Students and faculty members, please join me in welcoming the highly distinguished scientist and a visionary leader, Dr. V. Seshagiri Rao Garu. We are truly privileged to have such an inspiring personality with us today. Sir, the virtual stage is all yours.
Good evening to all of you. You are able to see my video?
Yes,
All of
sir.
you? Yeah, okay. How many of Google Meet persons are participating in this?
8, sir. All are watching this Google Meet in the YouTube live, sir.
YouTube Live. Okay. And thank you for generous introduction. And today's topic is on the present and future launch vehicles, both ISRO and as well as the global level. And I'll be talking about the launch vehicles in particular, and we'll be spending next 30 minutes in that. So let me share the presentation. You have the share option extended to me. 1 minute. Yeah.
అంతా బాగుంది సార్ నేను ఒక లెక్చర్ ఇప్పుడు మాకు ఒక లెక్చర్ నడుస్తుంది సార్ మీటింగ్ లో 7 టైప్ అవుతుంది చేయండి సార్ మన స్పేస్ లెక్చర్ సాటర్డే నడుస్తుంటుంది కదా సార్ జస్ట్ లో 7 తర్వాత
Sir, may I help you, sir?
One minute. You are able to see the slide
Yes, sir.
in the full screen level.
Not in the full screen level, sir.
What about now?
No, sir.
You are able to see in the slide share mode as it is, if not in full.
We are able to see in the slide share mode, sir.
Is it clear now?
No,
Or
sir.
you want to bring it to?
Sir, I think we can go into the slideshow so that we can able to see the entire screen, sir.
Okay.
అంటే కనిపిస్తుంది కదా సార్
What do you see now?
Yes, sir. Yeah, we can, sir.
Full one is visible to you?
Yes, sir.
Okay. Uh, yeah, once again, let me welcome all of you from the Kalam's enthusiastic members. Uh, this is a special session on launch vehicles of present and future. In this, you are seeing, let us say, a couple of space probes actually waiting to either take off or let us say to provide services if let us say the moon is colonized. So the bright dome is something where humans can stay in the coming maybe 20 to 30 years. And like our aerodrome, this is the cosmodrome on moon, and where a couple of rockets are standing there. So this is the artistic visualization of the cosmodrome. And Sriharikota is the launch complex for the entire space Indian Space Research Organization. This is situated in Andhra Pradesh, and it is on the equator and near to the equator, not exactly on the equator. Equator is 0 degree latitude, and whereas the launch complex is the 13-degree latitude. Uh, all the launches which have taken place so far, as far as satellite launchings are concerned, it is only from this place. And the moment you say rockets, there are two types of rockets. One is, let us say, probing the atmosphere. So when you launch a rocket, it conducts the atmosphere in the ascent phase, and it will not orbit the globe, and it will return back in the descent trajectory. That is one type of a rocket, and I will be covering that. And to launch such type of rockets, we have, well, ISRO has got one more launch station at Turles near Trivandrum. It is called the magnetic equator. So now I talked about two equators. The one equator where the middle of the globe of Earth at 0 degree latitude. And the other one is the uh, magnetic equator. So that means the both the north pole and south pole are concerned. You can see the equilibrium there, the neutral point. So there also in the magnetic equator, the TERLS is also used as a launch complex, but smaller rockets. So what is the advantage of keeping a launch pad in east is something where you are able to see the earth now, and the earth, our day and night are due to because of the earth rotation. See, the rotation time is 24 hours. The time taken to, let us say, to from a starting point again to come back to the same point is 24 hours. You know at what speed it moves? It moves around 1670 kilometers per hour. That means the earth is spinning at the rate of 1670 kilometers per hour at equator. That is equivalent to 330 meters, roughly 365 around that meters per second. So what happens, the moment a rocket takes off, when the Earth is moving from west to east, the rotational velocity is automatically added to the rocket. So that is something like when you are traveling in a bus. When you get down from a moving bus, you tend to move forward because you have the whatever smaller velocity the bus is having. The person is also at the time if the bus is about to stop, he gets down and moves forward along with the bus. Similar thing, the moment the rocket takes off, the rotational velocity of the earth is added to the rocket. So that is a huge advantage, without firing a single propellant, the earth rotational velocity is added to the rocket. That is the advantage. So we are at 13 degrees, more or less 1400 kilometers per hour additional velocity you get because of that rotation. So the moment you want to orbit any satellite, You see a person is standing on earth and he is throwing a stone. So you can see he has thrown a stone with a velocity A and velocity B, and both the stones landed back on the earth surface, whereas velocity C is uh, given such a velocity that the object is moving around the earth. So if the object is moving around the earth, the principle here is the gravitational pull to which an object is attracted to the ground, to the center of the earth, is neutralized by the moment of the velocity. So the kinetic energy and potential energy is it is called centripetal force and centripetal force. If you want to keep a satellite at 200 kilometers altitude, you need 7.8 kilometers per second velocity. And you want to put a satellite at 1000 kilometers altitude, you need 7.4 kilometers per second, which translates to 28,000 kilometers per hour. And similarly, all the geosynchronous satellites which are using for communication purpose, they are actually kept at an altitude of 35,800 kilometers, so that it moves around 3 kilometers per second. That is good enough because the distance from the Earth is 36,000. So the advantage here is the moment any geosynchronous satellite put at 35,800 kilometers, moving at 3.1 kilometers per second, matches with the Earth rotational velocity. That is why the moment you keep a geosynchronous satellite at a particular point, it is equivalent to, let us say, always it is on overhead to you. So thereby, you can get the communication continuously done at a given place. So as I said initially, the entire program, space program in ISRO started with the sounding rockets. We have so many varieties of sounding rockets, which is shown here. And the number of sounding rockets launched from Sriharikota is around 538. And whereas more than 3,000 sounding rockets are launched from the magnetic equator from TERLs. So there are varieties of sounding rockets here. It explores the both atmosphere and as well as the ionosphere with the experiment. You can conduct an experiment both in ascending phase and descending phase. We have Rohini 200, Rohini 125 was also there. You have Rohini 200, Rohini 300, Rohini 300 Mark II, and Rohini 560 Mark III. So both 560 RHS, Rohini 560 Mark II are two-stage rockets actually, Mark 1 and Mark 2. So 300 is also a two-stage rocket. So it can carry an experiment of, let us say, for example, 80 kg. The RH560 can carry up to 200 kilometers height. So that means from launch pad to 200 kilometers height, the moment you keep an experiment on top of the rocket, it will continue to do and do the experiment and collect the data. And both in ascending phase and it reaches an altitude, we call it as an apogee. And then again in the descending phase also you can do the experiment. You see here that is those rockets, sounding rockets are the Indian. These are the sounding rockets worldwide. There are so many. Everybody does, let us say, atmospheric studies, ionosphere studies. The atmospheric studies are very important to know the, let us say, weather about you. And ionosphere is very important to know how much radiation the ultraviolet rays can penetrate and how is the ozone layer, and many studies can be done. And when the radio waves are propagating because of ionosphere, some will get penetrate through, some will get reflected back. All the medium wave waves of All India Radio will get reflected back. And you have FM radios also. So these are the worldwide. And this is, the moment I say atmosphere, Up to 20 kilometers, we call it as a troposphere, where our aeroplanes will fly. And up to 50 kilometers, it is called stratosphere. And up to 85 kilometers, it is mesosphere. And the mesosphere consists of various, let us say, the electrons in different densities, and they are called the ionosphere. Uh, and later, about 80 around 100 kilometers and above, is called the thermosphere, and 500 kilometers above is the exosphere. So the troposphere, we know the balloons and rockets, as well sounding rockets, as well as the aeroplanes can fly. And stratosphere also balloons can fly. And mesosphere, you can see the meteorites which are coming from the other parts of the space. They, in case they enter, they get burned up. So all these studies, this is the right side is the trajectory. The moment the rocket takes off, it reaches an altitude maybe around, depending on the type of rocket, 400 kilometers or 500 kilometers, and it drops back. So you may ask why it is not orbiting the Earth after reaching 400 kilometers, because the moment it reaches 400 kilometers, the velocity is not there. Vertical velocity becomes zero. That is why it returns back to ground. So we all seen that in the earlier slide, you want to keep a rocket or a satellite in space, you require 7.5 kilometers per second and above. So that is the type. These are the atmospheric study and ionosphere study rockets. And remember, ISRO has launched more than, let us say, 3,000 from Tumba, and 500 and odd, 530 and more from Sriharikota. So these are the satellite launch vehicles. Till now, 102 launch vehicles were launched. SLV-3, for which the Kalam is the project director, it was started in 1980, and followed by SLV-3. It can take only 50 kg satellites, a maximum. And ASLV, it was started in 1992. It can take 100 to 150 kg satellites. And 1993 onwards, ISRO has moved in a big way. We have started with the PSLV. PSLV has got 6 strap-ons around the rocket. You can actually launch with 4 strap-ons, 2 strap-ons, and no strap-ons also. So PSLV has got many variants. And GSLV Mark II, we have started in 2001. And GSLV Mark III, we started in 2017. And SSLV, which is called a smaller launch vehicle, it is called launch on demand purpose. So if you take PSLV, it can take 1,700 kg into, let us say, low Earth orbit. Low Earth orbit, we'll see in the next slide what is the altitude. And GSLV Mark II, it can take 2,200 kgs into geosynchronous, that is 36,000 kilometers. And Mark III can take 4,000 kgs. And SSLV can take 500 kg, because small satellites can be launched at shorter notice. It is called, let us say, rocket on demand. And in addition to that, 5 experimental missions were launched. We'll see some of them. So in total, this is how it went on. If you look at it, we are celebrating, the Aryabhata related Utsav, and 1975 the first satellite launch, and ISRO in 1962 it was started as a COSPAR. 1971 it was named as ISRO, and then later on you can see how, let us say, the launch vehicles and satellites have been developed one after the other. So you can see the establishment of both in rocketry and satellites from 1960s to 2020. We are running in the 2020 decade. This is one launch pad where PSLVs are launched. You see an arc here. The rocket can be integrated at both the places, either at the left side of the building or right side. So the moment rocket is integrated inside, it is a huge tower and which moves back. So the rocket will get launched. So this is one launch pad at Sriharikota. And this is the second launch pad. Second launch pad also you can see you have 2 towers. the rocket can be integrated. That means what? If you have two towers, means two rockets can be integrated simultaneously, and you can bring it to launch pad, and it can be launched by bringing it to launch pad. So that is, the earlier one is integrate inside a tower, move the tower back, and the current one is uh, let us say you integrate in the building, move the rocket and launch it. Build, move, and launch. If you look at the total number of satellites up to July 31st, 2025, we have launched 528 satellites. Out of that, 132 are Indian satellites, and 396 satellites are foreign satellites. These satellites can be put in various orbits. If you say the low Earth orbit, the low Earth orbit is somewhere between, let us say, 300 kilometers or 200 kilometers to 2000 kilometers. Anything between 2000 to 22,000 or something is called medium Earth orbit. And the orbit around the equator is geosynchronous satellite, the moment if you keep at 36,000 kilometers. So they are all used for Earth observations. We have communication satellite, navigation satellite. You have apply various scientific experiments, and there are small satellites up to 1 kg to, let us say, 1000 kg. And we have the communication satellite INSAT type, Cartosat for Earth observations, GSAT for communications. We know about Chandrayaan. We'll come back on that. We have Aditya, which is studying the sun. We have SpaceX, where docking has been demonstrated. And currently, a month back, NASA ISRO synthetic aperture radar, that is NISAR, was launched. You can see this, the satellite applications are concerned. It can do wonderfully so many activities by observing from space. Let it be ocean monitoring, mining. They come under remote sensing. It is flood mapping, forestry, horticulture, and disaster management, the urban development, and the weather forecasting, and the water body monitoring, land management, environmental, and bushfire mapping. Many things. So if you want to do all these things simultaneously at a short test period, currently the constellations have come. The constellations consist of hundreds of satellites in various orbital planes, where more than one place can be seen simultaneously. And weather point of view, if you take as an example, in 40 minutes, the total weather on globe can be monitored in a single shot. So that is the advantage of communication satellites. The moment you say that if a rocket is to be integrated, how it will get integrated? This is the sequence of integration, where first initially the first stage and strap-ons will be integrated, and later on second stage will be integrated, the third stage will be integrated, fourth stage will be integrated. On top of fourth stage, you have the brain of the rocket, that is called the total electronics. On top of that, you have the satellite, and satellite is protected by a heat shield. It is called nose cone. While it is going through the atmosphere at high speeds, because of the friction, it gets heated up. In other words, it is also called heat shield. So to protect the rock satellite inside the rocket, the heat shield like nose is provided. So this is how the integration takes place. So you can see some of the integration thing on the right side. And you see, once integration is over, the propellant is filled. So if there is a solid propellant, there is no need to fill, because inside already solid is there. If it is a liquid propellant, the liquids, both oxidizer and fuel, will get filled. And if it is a cryogenic stage, liquid oxygen and liquid hydrogen will get filled. This is a, let us say, uh, a rocket where, the countdown point of view, it is a GSLV Mark II type, where, it takes around 29 hours to fill the entire propellant and launch it. So the moment it is launched, the radars, the telemetry, the ground stations will monitor, and everybody will start seeing the, let's say, trajectory of the rocket by sitting at the control center. This is the control center actually inside, when the rocket takes off. Before taking off, the filling is done automatically because it is such a, let us say, dangerous operation. Nobody will go nearby. Everything is automatically filled from the, let us say, filling control center, where people will be sitting in front of the control monitors, and everything is operated remotely. Once filling is complete, then the control center, T minus 16 minutes onwards, the computer will take over the launch operations. And once every parameter is normal, the computer ignites the first stage, and the trajectory is monitored from the control center. You can see here, these are the, you can see the inside view of the control center. You see so many experts are there. On top, you can see the video wall where the rocket is monitored before takeoff. And once it takes off, this is the type of, let us say, trajectories. The top one is the time versus altitude, range versus altitude, and the time versus velocity, and the event that takes place, because first stage will take the rocket up to, let us say, 100 kilometers. After 100 seconds, it gets separated, and later on, the second stage will get ignite. It will take up to, let us say, 290 seconds, and followed by third stage, cryo stage ignition for GSLV Mark II, and at the end of 15th minute, the satellite will get injected. This is various phases of the trajectory that is being monitored from the control center by various experts. So we have, you all know that in the mobile, you are having the navigation, location. All those things are done by GPS system. So India is also having a GPS system. It is called NAVIC. And in the NAVIC, we have 7 NAVIC satellites, and it is called regional GPS. It is the truly Indian one, and all the airborne systems, and as well as the ground-based transport, as well as sea-based transport, they can use Indian GPS for navigation. You all know that this is the Mangalyaan mission. This is number one as far as India is concerned, because there are many countries like, let us say, USA, ESA, Japan, China, and Russia, and many other countries. They have made so many attempts, but India has made one attempt which was successful first time itself, when they orbited Mars orbiter mission over Mangalyaan. This is a creditable one because we are number one. The first attempt itself we achieved success. This is the monitoring of the uh, sun from a Lagrange points. You are able to see a triangles here. So in the triangles inside, you see there are points like L1, L2, L3, L4. This is nothing but neutral gravity points of sun and the earth. That means the gravitational force due to sun and gravitational force due to earth will vanish at a particular point. If you keep a satellite at a particular point, it will not orbit the earth. It will stay at the same place. Uh, so that is called Lagrange point. The entire geometry moves. So always you don't require a fuel to, let us say, to control the satellite, and it will keep on monitoring the sun and providing the data to the earth. It's called Aditya. And the Chandrayaan 1, Indians are the first to say that through Chandrayaan 1, we have found the water molecules, OH ions. It was launched in November 2008 by PSLV. It has taken Chandrayaan satellite with moon impact probe that was suggested by Kalam to impact a probe on moon instead of landing as a first attempt. So this was done by the PSLV in 2008. And Chandrayaan 2, Chandrayaan 2 is remembered for its lander, where in the last minute it could not land, it crashed onto the moon surface, whereas the satellite or the orbiter of the moon is 100% working, and it is still orbiting the moon, and it has provided the photographs of the moon, and which gave the total atlas. So using the Chandrayaan 2 orbiter, the moon atlas has been made, even though lander is not successful. Even the orbiter was used as a data communication for Chandrayaan 3. This is Chandrayaan 3. So if you look at the Chandrayaan 3 videos, in the world, the most, let us say, viewed in real time a scientific experiment means it was only Chandrayaan 3. More than 100 crore people have seen it in real time when it is, let us say, landing on the moon surface. You can see here the moon surface landing and as well as the rover coming out. And it was launched on, let us say, in 2023. And August 23, it has landed. That is why we celebrated that as the National Space Day and 23rd August. Whereas the launch took place on 5th August 2023. And the entire landing completed by 23rd August. These are various experiments, it has got an experiment where you can study the particle content there. And these are various sensors that is kept on the lander, which has made a successful landing. So it is called soft landing. One is hazard avoidance sensor. So in case if there is a crater, or in case if the place is not horizontal, if there are so many stones, the hazard avoidance sensor will take a photograph, compare with the earlier atlas, and it decides in real time where to land. And also these experiments are done to find out the minerals like aluminum, magnesium, silicon, calcium, many things. And our experiments have found out the presence of methane and as well as sulfur. And also some more experiments were conducted, and the entire experiments were conducted for only 14 days. You are aware that the moon, we have 14 days daytime and 14 days nighttime. So on moon day means 14 days sunshine and 14 days dark. So 14 days daytime you get a temperature of plus 150 degrees centigrade. Then night time it is minus 150 degrees centigrade. So in the extreme cold temperature, the sensors and the experiments will not function. That is why it functioned for 14 days. This is the SpaceX mission where successfully the docking has been demonstrated, which is useful for Bharatiya space station, which is going to come up in the next decade. And you can see how the docking took place on the, uh, let us say, the SpaceX A and SpaceX B. This is the Subhan Shukla, which was flown in Falcon 9, the American rocket. And the Axiom 4 company, private company, took that, let us say, the project of taking Subhan Shukla with the three others. And they were all orbited successfully for 10 days and then brought back, which is a success story where, the human to the International Space Station experience is useful for our Gaganyaan. This is how the parachutes and the re-entry took place, and the Shubhan Shukla has reached the surface. This is our NISAR satellite. The NISAR is two radars on board. The NASA and Indian synthetic aperture radar. It has got L band and S band. It can monitor ocean, it can monitor earth crust, solid earth, and it can monitor forests, and it can be used for disaster management. And both it is a joint experiments of NASA and ISRO, and all departments, including irrigation, the weather, the oceanography, and many other government agencies will get benefit out of this. This is the other experiments where the R&D is going on for the reusable experiments are concerned. You can see one of the reusable things, that is how it has landed on the, uh, let us say, Chitradurga air surface. So this is the reusable R&D going on with ISRO. Uh, This is the Gaganyaan mission. Actually, Gaganyaan mission uh, is a prestigious one. We know the Subhan Shukla got trained. We have the 4 astronauts. They are also all theory work was done, and the entire experiments are required, like pad abort test and parachute test, and flying the crew module uh, testing it is completed. And first 2 flights will be without humans, and maybe third or fourth flight onwards it will be with humans. It's a pad abort test. And this is the next generation launch vehicle. Suppose if you want to construct space station like International Space Station, Indian Space Station, uh, a vehicle which can carry 150 tons is a must. So this is the one, and it will be used for crew modules as well as to the. This is also Gaganyaan one actually, where the missions will be without crew, and later it will be with crew, and later on it will be used for Bharatiya Space Station building also. You can see the prestigious 5 projects announced by Prime Minister of India is one. The first one is Gaganyaan to take humans to orbit and bring back, and you can use it as a tourist later. And building a new generation launch vehicle which can take 150 tons to the low Earth orbit, and building Bharatiya Space Station and Chandrayaan 4 and 5, and landing humans on Moon and bringing the samples. This is Chandrayaan 4. It will be one experiment. Chandrayaan 5 will be joint experiment with the JAXA, Japan. And this is Chandrayaan 4 to bring the lunar samples back. This is the next generation launch vehicles. This is the developmental pictorial view. And this is the sample return program, a pictorial view. And this is the Venus mission. The mini Venus is the planet where very sparingly the Venus atmosphere and the surface has been explored, and India is planning to explore Venus in 2028. Then this is the pictorial view of Bharati Antariksh Station, where the construction point of view, it has to be built in stages, and how many stages will be there? There are totally 5 stages. One by one, you have to take it up and dock it. And in the world, if you look at it, we looked at, let us say, the Sriharikota launch complex, and the Tumba, and as well as new one is coming at Kulashekarapatnam in the East Coast. These are so many launch complexes in the world. There are more than 100 new ones, future ones. Everything is shown here, and these are all the rockets by various companies which can take tons and tons of material into space. And you can see those rockets. They can be launched from sea also. You can see one rocket getting launched from a ship. It can be launched from a ship, and also if you recover the rocket back, the cost will come down. You can see the part of the rocket is getting recovered onto the launch pad. You can see the catch. See, what happens is if you recover back all engines, the cost will come down. So the currently, if you want to take 1 kg of satellite, it costs around 6,000. It will come down to maybe 200 to let us say $500 to $1,000. Last year, if you look at it, almost 263 launches were taken place worldwide, and they have launched around 2,800 satellites. This is something space tourism, and people will be taken to the space, and it will be brought back. They will be taken. If somebody is ready, you can buy a ticket at $1,40,000, and they will give 1 day training. You enter the liner and then go to the space, take a selfie, and come back. Total duration will be around 1.5 hours. So things are going on in space tourism also. This is International Space Station. Similar one India also wants to build. And this is something, the moon also is going to have the space station that is called Gateway. Let us say after a decade or 2 decades later, if you want to take a tourism to moon, this space station is going to help in a big way. It is called Gateway Orbit. And later on, people want to colonize the moon, where the structures will be built there itself. And these are all various rockets that are going to be used for such operations. So, if you take the lunar exploration roadmap, uh, the humans wants to go to moon and colonize, and there are attempts in the coming 2 decades to go to Mars, and then to see whether colonization is possible there, and various explorations related to the humans, both for communication and everything put together. So you must have seen so many rockets, so many space stations are there, so many launch stations are there. Many countries are working, and this is the ever uh, exploration. Space exploration is continued to be there for the centuries together in future also. So that's what the launch vehicles and the present and future. This is the Mars. Tomorrow, if somebody colonizes the Mars, that is how it will look like, a small colony and the rocket waiting there. So that's what I thought I will introduce the launch vehicles and the present and future. So thank you very much, and we'll take some questions. Yeah.
Thank you so much, sir, for that inspiring session. Your words add value to the young minds. So now we open the floor for a short Q&A session. If you have any questions, please drop them in the YouTube live chat, and we'll address a few questions right now. I request our guest, Dr. V. Seshagiri Rao Garu, to have few questions from our audience.
Yeah, go ahead.
Sir, the first question is from Vinay, Mahavir Institute. Good evening, sir. My name is Vinay, and I have completed my aeronautical engineering degree this year from Mahavir Institute of Science and Technology. What are the primary challenges in improving the efficiency and reliability of current launch vehicles, particularly from an aeronautical engineering perspective?
Yeah, good evening, Vinay. Actually, the any rocket, if you want to take humans to space, it is called human rated launch vehicle. Human rated launch vehicle is something where, when you are flying in an aircraft, what is the reliability you would like to, let us say, assign? Is something, the danger to the human is less than the danger when a person is walking on earth. When a person is walking on earth, either in their house or outside, what are the dangers involved? Maybe some kind of a injury, or some kind of a snake bite, or let us say a lightning, or an accident, or whatever it is. So it should be, when you fly in aircraft, your danger should be less than that. That comes to 1 in 10 lakhs. So that means it should be 99.99 reliable. Everything is put together. Reliability cannot be achieved with a single engine. You need redundancies everywhere. You need multiple engines. What will happen if there is a, let us say, when Air Force pilot is piloting an aircraft, uh, then if there is a danger, the aircraft will be jettisoned out. Similarly, when when the humans are being carried out, being, let us say, lifted to space, uh, if the rocket, let us say, becomes a dangerous one due to some reason, due to some failures, uh, like the pilots, the humans are also will get jettisoned out. So these are all related to reliability. And as far as the engines are concerned, so the current ISP, it is called specific impulse provided by, let us say, burning a kg of a fuel is highest for cryogenic engine. So being used is cryogenic engine. The next levels, they want to go for the plasma and related to the ion thrusters and nuclear propulsion. Many other things are there in R&D. When you come to such R&D things, you need the reliability, and the materials are very important. The material has to be light and durable, and so that when you carry the crew modules and all, the weight will come down considerably if the materials are strong and lighter. So these are some of the concepts one has to consider.
Thank you, sir, and thank you, Vinay. Sir, the next question is from Jayan from Sri Hindu College. Sir, what technologies are needed to make human life sustainable on other planets?
Somebody should tell what is being done in the aircraft now. When you fly from, let us say, um, Chennai to Delhi at an altitude of 10 kilometers, you don't have required, if you, let us say, if the environment inside the aircraft is not maintained, nobody will sustain because the oxygen is less and the atmosphere is less. That means the environment is provided, let us say, by artificial means. You have the atmospheric pressure, you are given oxygen there so that you can breathe in, and as if you are sitting in a bus on ground. So, such a level of chambers are required. You want to make not the colony, few humans to sustain either on the moon or international space, like International Space Station. Sunita Williams stayed for 9 months, more than 6 months, like that. So you need an artificial atmospheric environment for sustainability. So how to create that and how to make such large things on, let us say, the moon surface and wherever humans are put to live. Yeah.
Thank you, sir. Sir, what is your experience with APJ Abdul Kalam, sir? Can you please share?
Yeah, I have worked very closely with him, and when he was in ISRO with SLV, first launch vehicle, I was the person who provided the trajectory. Whenever there is a launch, in conference, you see the graphs in the control center. You see the graphs. Those graphs were provided by me, where the rocket position is minute by minute or second by second, what is its velocity and all. So I worked with him, and more than 2 decades, I had, let us say, communications with Kalam. And when he has moved to DRDO also, I jointly participated with Kalam in many works.
Thank you, sir. Uh, Now I invite our passionate student leader, Miss Siri, to present a question.
Good evening, sir. I'm Siri from
Good evening.
aeronautical background. Sir, I want to ask, like, in future, should we expect like anti-missile system from ISRO?
ISRO is the charter wise and the definition wise, it is only for peaceful purposes. ISRO will never attempt for any of the strategic use, any of the, let us say, the items designed and prepared, whether it be rocket motor or the rocket itself. So the moment missiles are required, it is completely done by DRDL, independently done, and that is why Kalam went there and he got an integrated missile project through which the Agni, Prudhvi, Akash, Nag, and many missiles were developed and tested. And BrahMos is the latest one, and which has worked wonders when the recent episode with the border is concerned. So that is entirely done by a different department. ISRO will never make missiles.
Thank you, sir. Thank you, Ms. Siri. Sir, the next question is from Vaishnavi from Gokaraju Rangaraju. What measures are taken by organizations like NASA, ESA, or ISRO to reduce space pollution?
No, in fact, this it is called space debris. So there are two things. One is the fourth stage, final stage. Some rockets it may be third stage, some rockets it may be fourth stage. The satellite along with final stage enters the orbit. Satellite will get separated and it will do its functions, whereas the final stage which has taken the satellite up to that altitude will also be in orbit. So that means that is an useless object which is orbiting along with the satellite. So those objects have got be removed by uh, the nation which has launched the satellite. That is called whenever a satellite is launched by removing the all spent stages is called the zero debris operation of the rocket. So India is doing some guidelines are prepared, and in addition to that, if there is a accidental explosion of the spent bodies or a satellite, some debris will be there in that particular altitude. So those debris is avoided whenever you launch a satellite. So that is why people use the collision avoidance software to keep the satellite in orbit. So those collisions are predicted. And space traffic management is also one activity where they are doing day in and day out. So, for example, Starlink satellites are 8,000 in number now. So every day they get a probability of at least getting half a dozen collisions. So they are actually avoided by maneuvering the satellite in, let us say, slightly different path. So space traffic management, space debris removal is going to be an ongoing activity forever.
Thank you, sir. Sir, before we proceed, I would like to ask, sir, can we have some more questions?
Yeah, no problem. Another 5 minutes. Yeah.
Sir, there's a next another question from Saroju Yadagiri from Sri Hindu Engineering College. Sir, how can space tourism evolve in our country?
The moment Gaganyaan is successful, indirectly, uh, uh, both Government of India and ISRO can look for starting the space tourism. Gaganyaan is nothing but taking humans and orbiting them for, let us say, the required number of days and bringing them back. Space tourism initially is like that, what is currently going on now. The second level is like Shubham Shukla. Take him to space station, orbiting him for about let us say a week and bring him back. Now currently, the most frequent one is taking them to an altitude of let us say 100 kilometers and bringing them back. That only for 1.5 hours. So those numbers are large. So one is spending 5 minutes in space and bringing him back. Second is orbiting for 1 week in a like Gaganyaan and bring him back. Third one is taking him to International Space Station and bring him back. And fourth one is taking to Moon and bring him back. The fourth one is still many years away. And third one that you have seen already, Subhan Sukla and Sunita Williams kind of people. And anyway, Gaganyaan type is coming up, and many countries have done it. And space tourism, with many spacefaring nations or private companies are also doing. It is doable.
Thank you, sir. Now I invite Ms. Akshita to present a question.
Good evening, sir. I'm Akshita from Vignan's Institute of Management and Technology for Women. I was eagerly waiting to know what are the biggest engineering challenges in designing reusable rockets, sir.
Yeah, you have seen one reusable rocket getting captured in the presentation.
Yes, sir.
Yeah, with audio it has come. So the challenge is it has to carry an additional fuel. Each motor, each stage has to carry an additional fuel, and that is also to be brought back in the controlled environment without getting burned in the atmospheric friction. So that is why it has to be covered with, let us say, the tiles where it will withstand a temperature of 1600 degrees centigrade while entering back. So that is why there is re-entry is a challenge. And number two, by carrying additional fuel, you are reducing the capability of taking the payload weight into the orbit. Number two, and number three, you have to bring it to a place and where it has to reuse. Suppose if you take it to a forest, if you take it to many other places, you bring them is a challenge. So if you bring it back to the launch pad at a identified place, reusing them is useful. And you see that a particular one which was shown in the presentation, it was captured on the launch pad arms itself. So many challenges are there. You have to perfect it.
Thank you, sir. Thank you, Akshita. Sir, there's another question from Muhammad Zahur from MGIT College. What are ISRO's future strategies to compete with the global players like SpaceX, NASA in satellite launch services?
See, to compete with the global players of any country and in a private setup is concerned, we have the capability and technology. We have demonstrated it. Nobody has orbited first time Mars. We did it, and next time sending is easy because technology is known to us. Similarly, nobody has landed on the South Pole. Till now, nobody has landed on the South Pole of the moon. We could land and demonstrate. And next time you want to do, you have got the expertise. And the Gaganyaan is going on. Before Gaganyaan, a satellite recovery experiment was done. Without humans, a satellite was orbited for 7 days. That has been brought back and let us say splashed in Bay of Bengal and was recovered successfully. And there was another experiment, docking is concerned. We have done a SpaceX docking. Two satellites were sent simultaneously on a PSLV rocket, and when they are flying one behind the other, docking was made and it was successful. Now, if you name a technology to do all the works like other countries are doing, we have the technology and we have as well demonstrated. It is only the question of when you want to construct a, let us say, international space station, when you want to go for, let us say, you're bringing the samples from moon, you have to decide, make a project. Already you know that the 5 projects are there. India is planning to bring samples. India is planning to construct Bharati Antariksh Station. So by 2047, the all these things will be realizable because we have already got the technology which is demonstrated.
Thank you, sir. Sir, Mr. Manish from Narasimha Reddy Engineering College wanted to know that is Gaganyaan mission getting any help from abroad countries?
Yeah, abroad countries, as far the astronauts training is concerned, it was done because creating zero G and as well as when you are taking off, you have to expose it to 3G, 4G condition. So all those things training is concerned, the astronauts has been trained in abroad and even to make a space suit, some of the subsystems we may have to buy and integrate here. It is like that. And you know, Axiom has helped to take Subhan Shukla to a international space station and bring him back successfully. So these are the things where the external help was taken. And as far as the required rocket is concerned, capsule is concerned, making the preparations are concerned, ISRO is doing on their work.
Thank you, sir. Sir, I am Deepshika, currently pursuing final year from EC department. Sir, what advice would you give to EC students aspiring to work in space research or organizations like ISRO?
Yeah, actually, there are many things. AI and ML is coming in a big way. For that, you need the computer boards and the embedded software. And in addition to that, the sensors actually, the sensors for remote sensing, the visual cameras, infrared cameras, and RF sensors, and the sun sensor, the magnetic torquers, and the many, let us say, the telemetry, the radars, and space debris management purpose from ground, interplanetary purpose. You know, Voyager, which was launched in 1975, just crossed one light day, and it is about to go out of the solar family. So the electronics which was launched in 1975 is still working. And there is a lot of scope for developing many useful electronic circuitry that is required for space. The thing is, there is a difference between the electronic board, computer boards, whatever people make on earth and whatever being used on space. In the space you have the alpha beta gamma rays and UV rays, and all these rays are, let us say, filtered out by atmosphere. So your computer motherboard is, let us say, the uh, earth atmosphere tolerance. As far as you make any computer or electronic circuitry, you have to make it as radiation hardened. So radiation hardened motherboards and electronic sensors, take it from me, all the components in satellites, all the components in ISS, and most of the components in rocket, especially the navigation control, the navigation guidance and control, all are radiation hardened. So the radiation hardened, most of the electronics is imported. If you want to make radiation hardened items and many things in a miniature mode, it is a challenge, and people can do wonders if they try to, let us say, innovate in their own way.
Thank you, sir. There's the next question from Islam Khan. Good evening, sir. I am Islam Khan of Mahavir Institute of Science and Technology. I have a question about when we will get own Indian GPS available for civil purpose.
They own Indian GPS with regional GPS, because our GPS is on NAVIC 7 geosynchronous satellites. It is already available, but only thing is, somebody has to make a miniaturized receiver that can be put in a mobile. Once that is there, it is going to be available for, let us say, mobile use. I understand there are few companies they have already made the miniaturized version of the receiver, and I can say the mobiles which are coming maybe 2 years later will have the GPS with Indian satellites also.
Thank you, sir. Sir, there's another question from Aravind Rangisetti. How do the emissions from launch vehicles are controlled and reduced, sir?
The emission, if you take the solid propellant, yes, there is an emission, most of the aluminum powder, the solid propellant. And if you take liquid propellants, there is an emission problem because the fuel and um, oxidizer mix, you have the oxides. And if you go for cryogenic engine, the cryogenic engines function with liquid oxygen, liquid hydrogen. The moment liquid oxygen, liquid hydrogen, you burn it, you get water vapor. So that is not a, let us say, danger to the environment. So slowly people are working out on the green propellants with, let us say, methane and LOX and many other things are coming up. So if they are successful in providing the impulse required for the rocket, all these, let us say, the emissions problems will go away. Eh, and take it from me, some of the rockets are only right from first stage onwards, the semi-cryo and cryo engines. We can say the cryo engines, as far as liquid oxygen, liquid hydrogen is concerned, the water vapor emission is not a danger at all, except the temperature. So already I think many people are working on bringing the green propellants into action.
Thank you, sir. Now I invite Ashia Muhammad to present a question.
Good evening, sir.
Yeah, good evening.
Sir, actually, my question is as we know that we are going to have a Venus mission, also known as Chandrayaan, launching in year 2028. So, what are the major objectives that we should focus on this research mission, sir?
No, one is the surface, what type of surface it is they want to study, and the atmosphere they want to study. And future, if let us say You all know that when you want to get balloon essence in balloon essence studies, if you want to make on Earth, the flotation is because of we are able to do it because of the uh, atmosphere present on the Earth. And similarly, the aircraft when it takes off after a critical speed, on the runway, it actually the takeoff into the higher altitude will be let us say achieved. Similar things, if you want to do, you need the study of the atmosphere, its constituents, whether it is doable or not. And in addition to that, the technology, it is something where, very far off. If you want to take a human to Mars and brings back, you need anywhere between 2.5 years. What do you do when 2.5 years is concerned? The communication part and as well as the human safety part is concerned. What do you do? Many things can be done. And if you look at the website ISRO, the Chandrayaan mission, what is being done is given in detail.
Thank you, sir.
Thank you, sir. Thank you, Harsha. Sir, there's another question from Kirtan Reddy. Sir, advice and roadmap for mechanical engineer students from your side.
Actually, if you take the uh, after the rocket design on paper, uh, if I count all nations, all private companies put together, at least there are, if you take last year, 263 rockets were launched. Not sounding rockets, only satellite launches. 263 from at least 10 government countries, government agencies, and rest of them another 15 to 20 are private agencies. The design part alone, you need an aeronautical engineer. Then when it comes to materials, when you want to make a subsystems required for mechanical parts are concerned, the majority of the employees in all the companies put together, if you count, the percentage is more mechanical than aeronautics. No doubt on that.
Sir, thank you, sir. Sir, is it okay to have few more questions, sir?
Yeah, we'll go up to another 2 or 3 questions, no problem.
Okay, sir. Sir, there's a question from Zahur MGIT. Is there any international collaboration for Gaganyaan? If there, what are they?
That's what we already discussed. I think the astronauts training and such things are the concerned. We took the support, whereas crew module and the rocket and human rating of the rocket and all these things are concerned purely ISRO design.
Okay, sir. Thank you, sir. What role will AI and robotics play in future Gaganyaan missions?
Yeah, actually, the many things can be done. In fact, instead of the crew, the Vyomamitra is the first robot that are being carried on the uh, uh, human. Let us say without humans, a first Gaganyaan mission, crewless mission, but with a humanoid robot called Vyomamitra. So the moment it is Vyomamitra, it has to function based on AIML only. It cannot be like human where it takes and looks at readings and the dashboard and synthesize in your brain and take a decision. It's not because humans are not flying. So the moment the first mission is Vyomamitra means 100% you depend on AI and ML.
Sir, thank you, sir. There's another question from Vaishnavi from Gokaraju Rangaraju. What is ISRO's long-term plan to tackle the growing problem of space debris and ensure sustainable space exploration for future generations?
Yeah, space, ISRO is concerned, first thing they are already doing, the geosynchronous satellites, which are not at all functioning, it is if the lifetime is over, they have to be pushed back to the graveyard orbit. So that means you keep some fuel pending to push it to graveyard orbit. That is being done. And number two, the spent stages have to bring back without orbiting the, let us say, the along with the satellite. So they are taking a few kgs of additional fuel, and spent stage is fired back to a certain altitude and lower the altitude, and it will enter. So our launch vehicle is zero debris mission, because except satellite, none of the rocket debris is allowed to be present in the space. And the third one is ISRO has got Netra. Netra is nothing but ground-based radars, which I have also developed a multi-object tracking radar, where the space objects at a long distance can be tracked, and their details can be given 24 by 7, so that the collision forecast can be done, and the space traffic management can be done meaningfully. That's what going on.
Thank you, sir. Thank you so much for that interactive Q&A session. Your answers to our young mind questions are inspiring. Thank you,
Okay,
sir.
thank you.
As we come to the close of this remarkable session, I invite Miss Arshia to present vote of thanks. Miss Arshia, over to you.
Good evening, everyone. It is indeed a great privilege and honor for me to deliver the vote of thanks on this remarkable occasion of Kalam's Institute of Youth Excellence. First and foremost, I would like to express a profound gratitude to our respected speaker, V. Sheshagiri Rao sir, whose enlightening session has truly been inspiring and thought-provoking. The valuable insights have not only expanded our knowledge on the cutting-edge space innovations, but also ignited a spark in the minds of young aspirants to dream big and think beyond limits. Thank you for taking your time and sharing your expertise, visions with us today. I would also like to thank our sincere thanks to Dr. G. Satish Reddy sir, former chairman of DRDO, whose unwavering guidance and support remains the backbone of the KIYE Foundation's mission. His mentorship continues to inspire us to reach new heights in the field of science and technology. We are equally grateful to Prakash Chauhan sir from NRSC ISRO, whose dedication and efforts has been crucial in shaping and in learning opportunities to the student community. A thanks to Narayan sir, ISRO chairman, for his visionary leadership and continued support for the space education and research. Your role in advancing India's space capabilities and inspiring the next generation of scientists is truly commendable. We are deeply grateful for your encouragement and contribution towards such meaningful initiatives. Also, and not forgetting, a special tribute must be paid to a great visionary, Dr. APJ Abdul Kalam, whose life and ideals continues to guide us. His dream of empowering youth through knowledge and scientific excellence remains the very foundation of this initiative. I would also thank our entire KIYE organization team, our technical volunteers, and everyone involved in making this event a seamless and successful experience. Most importantly, a big thank you to our enthusiastic audience for your active participation and keen interest, which motivate us to continue this journey. Let us take this forward, inspiration and knowledge from today's session, and work with a renowned dedication towards making India a global leader in science, technology, and space research. Before I conclude, I am pleased to announce that the next lecture in Aryabhata Space Utsav lecture series is announced for October 18th, which is the third week of the next month. We are looking forward for your active participation and continue enthusiasm as we explore more topics together. Thank you once again to our respected speaker, V. Sheshagiri Rao sir, for your time and wisdom with us today. Wishing you all a wonderful evening ahead. Thank you.
Okay.
Thank you, Arshia,
So,
for the Thank you, Arshia, for those wonderful words of gratitude. I would like to end this session by extending heartfelt thanks to Dr. G. Satish Reddy sir for mentoring KIYE, followed by sincere gratitude to ISRO Chairman Sri V. Narayanan sir and to NRSC Chairman Dr. Prakash Chauhan sir for their constant support and guidance. We are truly honored by their encouragement towards the Aryabhata Swarna Jayanti celebrations organized by KIYE to commemorate 50 years of India's first satellite, Aryabhata, and to inspire young minds in the field of space research. Also, I thank everyone who joined us. Thank you for being part of Lecture-6 of Aryabhata Space Utsav. Let's continue this exciting journey as we explore new things in science and space. And I request everyone to subscribe our YouTube channel, KIY Foundation, for future sessions, and also join our official WhatsApp channel for the updates and announcements. Links are provided in the description. Let's stay connected, stay curious, and keep reaching for the stars, because truly, strongly we believe that space is the next destination. Let's explore it. Have a wonderful evening, everyone. Thank you. Jai Hind.